Pulsar is a two-layer system. There's a serving layer and a storage layer. Pulsar brokers serve as the serving layer. So the Pulsar broker itself is the one that's interacting with the producers and consumers. Bookkeeper bookies are acting as the persistent storage layer. And bookies are individual nodes within Bookkeeper. And typically each topic is replicated across multiple bookies. Separating the serving and storage layers enables them to be scaled independently, and we'll dive into why that's beneficial in a few slides. Data is sent to Pulsar topics by producers and read from Pulsar topics by consumers. Multiple consumers can read from the same topic. For instance, a retail company might have a machine learning model and an alerting system, both consuming messages from the same inventory database. Each single partition topic has a single Pulsar broker that owns it. A topic with multiple partitions will be spread across many Pulsar brokers, and this is how Pulsar scales. This single Pulsar broker serves all the reads and writes to the partition topic. In other words, all writes to the topic from the one or more producers and all reads from the one or more consumers go through that specific Pulsar broker. While the Pulsar broker is the entry point for reads and writes to a single partition topic, only one of the 3 or more bookies used to replicate storage for that particular topic are needed for a read. However, for tail reads, those don't require a bookie and are simply read from the Pulsar broker's queue. This cache memory is also referred to as topic compaction. Topic compaction keeps the most recent value for each key value pair in memory. This structure, where a single broker owns all messages from a topic, has 2 primary benefits. So firstly, the Pulsar broker can keep the most recent message or messages in memory. The most recent message or messages is referred to as the log tail. This cache can then serve the tailing messages to the consumers more quickly than if consumers needed to retrieve the data from storage on a bookie. If a consumer tries to read a message that isn't in the Pulsar broker cache, then the consumer will need to request the data from a bookie. This process takes longer than reading from the cache. That means that catch-up readers have a poorer serving performance than tail readers. And then the second benefit to having a single Pulsar broker owning a partition topic is that it is aware of the ID of the last confirmed entry. This is beneficial if there's a failure of either one of the producers or consumers. We covered a lot here, so let me summarize with what's at the bottom of the slide. So each single partition topic has a Pulsar broker that owns it. A topic with multiple partitions will be spread across many Pulsar brokers. Only one bookie is needed for a read, and in the case of tail reads, those can be read directly from the Pulsar broker queue. Topics are just one layer of data organization within Pulsar. There are also namespaces and tenants. Many topics can exist within a namespace, and many namespaces can exist within a tenant. On this slide, I included a photo of a grocery store to help paint a picture. So in the case of a grocery store, there's lots of different veggies or vegetables, and all of those could represent all of the different topics. And then all of those veggies collectively together exist within the produce department, which we could think of as the namespace. And then there's lots of different departments within a grocery store, which would be the tenant. A Pulsar topic is a category or channel name in which messages are published. Topics do not need to be explicitly created within Pulsar. If a producer tries to write to a topic that doesn't exist yet, then Pulsar will automatically create that topic. And the same goes if a consumer tries to read from a topic that doesn't exist yet, Pulsar will automatically create it. The namespace and tenant can be specified, but if not, then the topic will be created in the default namespace and tenant. Namespaces are used as a grouping mechanism for related topics, and there's no limit to the number of topics included in a namespace. Tenants are an administrative unit used to allocate capacity and enforce authentication and authorization schemes. Multiple namespaces can reside within a single tenant, and tenants can exist across clusters. Towards the end of this lesson, we'll be getting more into authentication and authorization when we talk about security.